this is Gil. I'm going to give you guys a demo on how to implement arcade mode on a VEX controller using our RobotC. So in this program you'll see a main task starts out initializing 3 variables. So these variables, left stick X, left stick Y, these are the filtered values of the joystick. After you've read them, we want to store an intermediate value from the joystick. So the X value is used for channel 4. You'll see in the picture here, channel 4 is left and right on the left stick. Left stick Y is the filtered value of a joystick for channel 3, right? Channel 3 you see is up and down, representing the Y-axis. So then the last thing, or the next variable we want to set is joystick tolerance, and this is the value that the tolerance for the joystick that sometimes happens when you release and it doesn't go back to 0. We know the joystick sometimes will have a few values in it, and we don't want to, when we release the joystick, have the motors run. So we're going to say anything below plus or minus 5 counts on the joystick is going to be treated like it's 0 or the motor is off. So to implement that logic, the while loop here, which is continuously running, first task is to read the value of the Y value, right, channel 3, and compare it. It uses the absolute, this is a function that's built into RobotC, which gives you the absolute value of the input. So we give it the channel 3 joystick value, and it's going to always turn it positive. So if it's -5, it's going to make it +5, and make sure that you're only dealing with positive values. And then you can easily compare it to your joystick tolerance. So if the joystick tolerance is greater than 5, you're going to set the intermediate integer here, left stick Y, equal to the channel that you've checked. If not, the else statement's going to become true, where the left stick Y will get set to 0. So that's saying that anytime the channel 3 is between -5 and +5, then you're going to be assigning 0 to the left stick Y variable, which then later we're going to be assigning to the motor. Lines 51 through 58 really just do the exact same thing. Instead of setting using the channel 3, they use channel 4, which is the left and right, and they set the variable left stick X. Once you have both those variables calculated, you can then implement arcade drive. And so the algorithm for arcade drive is pretty simple, but you got to kind of think about it a little. So we have 4 motors here. 2 are on the left side, front and rear. 2 are on the right side, front and rear. And for the left side motors, we're going to set the value of the motor power to left stick Y plus left stick X, both the same. And then the right side's going to get set to the opposite, left stick Y minus left stick X. So let's think about why that works. If you are going full forward, left stick Y is going to be 127, left stick X is going to be 0, and therefore you're going to be, both the left and the right motors are going to be full 127. You're not going to turn, you're going to go forward. And I'm sure you can see how that would just be this exact opposite when you're going full reverse. Now let's say that you turn the left stick right, which implements a component of left stick X. So if you start turning or pushing the stick to the right, left stick X is going to be positive, and you're going to be adding to left stick Y. At the same time, for the right motors, you're going to be subtracting, which is going to make you turn to the right. It makes sense until you get all the way where you just have the the left stick X component is full over and the left stick Y is 0. And if you see in that situation, the left motor and the right motor are going to be opposite of each other. So whatever you have here is going to be 180, or the negative of the right motor. Sorry, the left motor. Makes sense? So then you're going to be in a full turn, and it works the opposite way when you go to the other direction. So that's it. That's all there is to it, and this just repeats itself as fast as you can. The weight function is just used to make it so it doesn't go as fast, and therefore you give the loop some time to not have to run as quickly, and your microcontroller is a little happier. But I don't think you actually even need that wait symbol, because I think you get the task main has a way of implementing that under the hood. Hope that gives you guys a better overview of arcade mode for VEX. Good luck.